All right, so hopefully you've got some practice finding percent increase and percent decrease. So now we're going to get into the actual graphs of exponential functions. So the first thing we need to do is we need to talk about asymptotes. So an asymptote is a invisible boundary on a function that we scoped. So that you sometimes we draw asymptotes into graphs, but we always use a dashed line because this isn't a part of the function, it's more of a border for the function. So a border the function does not cross. It also never touches the border. And we're also going to usually be approaching the asymptote. So we're getting really, really close to it, but we never cross it. And I'm sure you've seen these before, but we have to talk about them because this whole problem set's going to ask you. So what I've done with these is I want you to do these on the paper provided. But to show me you've done them, rather than take a picture and turn it in, I'm going to have you submit 3 different parts of questions on Delta Math. So what I'm going to do is I'm going to go through the first one with you, and I'll do part 1 or part A as one video, and then part B as another video, and part C as another video, so you can see how it's chunked up. And then when you do the problem, I want you to do it the same way. You'll do it on the paper, but then you'll go put your answers into the Delta Math questions. So right here, for question 1, we have y equals 2 to the power of x. So the first question just asks, is this growth or decay? So all you really have to do is look at the b value. 2 is bigger than 1, so this is a growth function. So we're going to circle growth. In fact, over here, because... Okay, so that's really all you have to do for the first part of the question 1. So question 1a, we're just going to go and we're going to say, is it growth or decay? So you just look at this b value. If it's bigger than 1, it's growth. If it's smaller than 1, it's decay. So go ahead and go do that right now.